Hi guys, welcome back to SnT Networks. In today's video, we'll be talking about the third part on the series, network interview questions, network engineer interview questions, uh, along with the answers, part 3. So it's a series basically from basics to advanced. So we're in the third part of the series right now. And in this video, we'll again be discussing around 5 questions and we'll discuss on how to understand them and how to answer them in the interview. So without any further ado, let's start. The first question, what is a firewall and how does it work? So basically, if anybody asks you this, right, you need to know that firewall is basically any sort of network security system that monitors and controls incoming and outgoing traffic based on predefined security policies or rules. And it is basically a barrier between the external network and your internal network. So for example, this is your network. This is your internal network. Okay, these are the routers. Okay, and so this is the external network. This is you, the user, right? And this is a different network, office network. So we need to make sure the office network is secure, right? You need to make sure that security is there. So just to make sure the security, we divide this basically into an ideology called planes. Okay, zones or planes. That's different, but just understand this will be internal and this is external. Remove the user. It can be anything, any n number of users outside, right? Any user here, any user, person, system, bots, whatever. So we need to make sure that the internal system is secure, right? No attack happens, nobody can access the data. So in the middle, just a second, in the middle right here, we'll put in a thing called a firewall. So, and we can just use some rules on this, security rules, policies. So using these rules and policies, we can make sure that internal network is secure. So just like a router will, separate a network into no two interfaces can be in the same network. Like a switch is a broadcasting domain, right? And similarly, just like that, a firewall, right, is a security device, right, which will basically monitor and control traffic. So if any traffic goes in or out, it flows through the firewall. So as per the security policies, only if the policy says allow, only then that particular traffic will be allowed. So basically, how does it work? So firewall will basically examine the network traffic and compare it against the rules, that rules you have selected. Okay. So for example, you are saying for this particular network, we draw something. We have 1, 2, and 3. Okay. I have rule number 1 that from 1 and let's name this system as 4. Any server outside. This is a server. Okay. From 1 to 4, it is allowed. Second rule that we have, from 2 to 4, it is denied. Okay. Now you see, now there is a packet which flows, for example, from 1 to, I have a packet which is flowing from 1 to 4. It says it is allowed. So you compare it with the set of rules and policies and you let the packet flow across. Which device will let it? The firewall. Okay. Similarly, there's another packet. 2 also wants to send a packet from 2 to 4. But now it compares it against the policy and it says no, 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 I can't allow it. Okay. So how do you compare? You have a list of security policies. There are n number of things. The security rules are basically ACLs, right? Other than that, you have a lot of security features in next generation firewalls or traditional firewalls, right? Both of them, you have a lot of features. Like you can talk about application control, you know, uh, content control, URL filtering, right? Uh, there are n number of things, IPS, IDS. So accordingly, it will check and it will not let the traffic flow through. Move on to the next one. explain the difference between symmetric and asymmetric encryption. This is again a good one. So basically, let's talk about symmetric encryption first. What is symmetric encryption? So basically, for example, you have two users here, okay? Users, servers, whatever you call it, okay? And they have a secure channel in between. By secure, I mean it is encrypted. So definitely they would need a key for encryption and decryption, correct? So they have created a key. So simple example would be SSL. Okay, you take the SSL, you understand everything, but yeah, SSL, IPsec, both of them will use a key. So let's get back to the example. So you have a key, right? When you use the same key for encryption and decryption, for example, you're trying to send a packet from here to here, you have encrypted it with this key. You have sent it here. Now, the other user, this is A, this is B. B has the same key, exactly same key, and it is using that same packet to decrypt the packet. Okay, that same key. Then it is symmetric encryption. Okay, now this is pretty simple. This use the same key for encryption and decryption. Now, but when it comes to asymmetric, what exactly happens? We basically use two keys for encryption and decryption. For simple example, again, A and B, I have a key here. Okay, I use this for encryption, and I have a different key here. I use this for decryption, which gets me the same packet. Okay, but how does this logic work? How can you use two different keys, right? So basically, you can say that it uses two separate keys for encryption and decryption, right? And usually what happens is, for example, you're a user, okay, you try to access something from the internet. So on your browser, you will see something as HTTPS Google, right? And inside it, you're trying to, since it's HTTPS, it means encrypted and it is SSL plus secure. Okay, SSL means secure. Okay, so you are accessing a secure site. Now, when you see it, you need to understand that if there is a key, there is encryption and decryption going on. And if there is encryption and decryption going on, you have a key. The vice versa. So now, since you have a key, the simple logic behind it is like, you know, they'll even the server will have a key. Correct? Let's name it. The server has a key. So when you try to access the file, right, the server, when it's server hello will send you a public key. This will be in its certificate. If you want to know more about the certificate verification, please click on the I button and definitely you'll get to know it in detail. We have a separate video on that. So now when you have the public key, so you'll use this particular key for encrypting. You have a public key, let's name it this. But the server will have a private key also, which it will not share. Obviously, for security purposes, server's private key is this. So what you do is you encrypt the packet, share it across. Server will use that same key to decrypt the packet. Simple. So it is usually, public key, because the public key can be freely distributed while the private key must be, kept as a secret. In this way, we basically use one key for encryption, other for decryption. Usually public for encryption, private for decryption. Okay. Now the third one, what is a VPN? How does it provide security? Consider you're a user trying to access anything on the internet. Okay. Or yeah, so there you don't need security much, right? Because you can access anything, doesn't really matter. No confidential stuff, right? No company bound stuff. But you're a user at home and it's raining in Bangalore. Okay. You can't go to office. You need to access something on the office network, and they tell you you need to you need to use a VPN when you're at home. Now, why do they tell you that? The simple answer is this is a corporate network. You have servers here, right? You have devices, you have databases, everything. Now, in order for a user to access anything in the internal office network, right? What you need to do is you need to create a secure channel. So it's basically, you can say that if you're accessing something on the internet, right, you don't need much security. And when you're in the office, again, when the same user goes to office, right, the same user goes to office and is accessing something, they don't need a separate channel. But we are accessing something over the internet. There will be lay of underlay here, right? A lot of underlay devices. This comprises of the internet. So now in order to access something, you need a secure channel or secure mechanism. This is where the VPN tunnel comes in. VPN is a virtual private network, right? Which creates a secure and encrypted connection over a less secure network, such as the internet. Okay. It allows users to extend the private network, like I told you. It'll just extend the private network, right? Sending and receiving data as if the devices were directly connected in the network. Okay. So this is how you basically use the office data very securely. So VPN helps you in that. So how do we you do it? It uses encryption and decryption. It can be both symmetric, asymmetric. We use authentication to make sure the correct user is connecting. No exceptions. No one authorized should access. And then tunneling. Tunneling is basically the tunnel that you have created in order to access data securely. Okay. So this is VPN, and this is the way it provides security by creating a secure channel. And the next question is, what is network intrusion detection and prevention? Okay. So what is network intrusion detection? So basically, it is, you can call it in two parts. One is IDS, other one is IPS. Okay, sorry, IPS. But nowadays people club it into IDP. Single module. There's no need for two modules. That does not really make any sense. IDS is intrusion detection system. IPS is intrusion prevention system. Okay. By intrusion detection system, what it means, you have a network here. Okay. I have a network. These are my couple of devices which are connected to the network. Okay. And it is also connected to a different network. Doesn't matter. So what on this I have IDS on, intrusion detection system. So on this particular device, I will monitor traffic. Okay. For any suspicious activity, correct? And I'll alert the administrator, letting them know that there is a potential attack. Intrusion detection system will basically detect potential attacks or signatures. Now, how the IDS works? So again, I have a separate video on it. If somebody wants to check it out, go ahead. Right, but basically what it means is, if you have a device and a packet which is not meant to go in goes through, it will create an alarm. This is the IDS. Now, what does it detect usually? It detects anomalies, threats, or vulnerabilities. Okay, you can just call it threats. Now, what are threats? Threats are usually identified using signatures. So, for example, if you can say that I am at office and there was a virus that was detected. Now, IDS part will also help you with that. Not just virus, it detects signatures-based algorithms. Not just algorithms like signature-based attacks. You can say that packets or attacks. So, basically what happens is, now when a packet, so I have a database of signatures here. So for example, I have 20 signatures here, okay, and I have a packet coming in. Now I'll compare it with my signature database. If it is matched, I'll raise a trigger and raise the alarm also. If not, I will let it pass through. So it is not like ACL. If it is matches, it will be stopped. Okay. So now here it will just detect and let them know there is a threat. But IPS, prevention system, what it does is, similarly, I have another device called IPS, intrusion prevention system. Now, wherein if I see any attack, I see if similarly same packet is coming in, I have 20 signatures. Now here it sees, okay, it is matching. It is a match. Now at this point of time, it will not just detect it. It will prevent it. It will stop it right here. It will not let it flow through. But in terms of IDS, it lets it flow through. Okay, it just triggers it. So this was not making any sense previously. So now what we started is we created IDP. Now if any packet goes through, it is if it's again 20 signatures, if it is matched, right? We stop the packet, we alert, we do a trigger also. Either in mail alert is different, trigger also. So this is how the IPS and IDS work. Okay. Now we have the next question, which is what are common network troubleshooting tools and their uses? So we're talking about common network troubleshooting tools. There are a few, right? But the simplest ones that I would want you guys to properly use because it helps in everything. First is a ping one. Ping lets you know if you have reachability. Okay, reachability, and it also tells you the round trip timer. RTT, sorry, RTP, I'm sorry, RTT, round trip time. That how much time does it take to for the packet to go, to and forth. Then you have a trace route. Next one. It tells you how many hops does it take for you to reach the device and where exactly is the packet dropped. This is a good question, right? You can see that, okay, this device drops my packet. So you can troubleshoot that device directly. This is very helpful. Then you have, even in traceroute depends on the system. Traceroute usually works in Linux. For Windows, you can use traceroute. The next one is ipconfig. This tells you about the interface details, basically. Network configuration, host, IP mask, all of that, right? It's either ipconfig or ifconfig. Again, ipconfig is for Windows and ifconfig Linux. Then you have nslookup, which you can use basically to query any DNS, right? It is used for DNS to find out the IP address, right? And again, very important tool for the any network engineer out there is TCP dump. This helps you collect data. Collect data, view as a log, or you can even use Wireshark to see the log where exactly it is dumped. So even Wireshark is a very, very big topic. If you are able to understand Wireshark, then you are very close to becoming a fully fledged network engineer. Because any topic you can basically capture on a Wireshark and understand it really well. So these were the 5 interview questions we discussed in part 3. We'll be back next week with another few series. We'll move on to a better moderate set of questions. And this was easy to moderate level, right? We'll take it a notch up. And if you guys have any questions or you want me to discuss any questions, please do let me know in the comment box and we'll definitely do so. Thank you. I hope this was helpful. Thank you. Bye bye.